All right, in this video, we're going to be talking about graphing points in all four quadrants using ordered pairs of rational numbers. So what this basically means is that we're graphing coordinate pairs in all four quadrants instead of just one. Now, when you first started graphing, usually you graphed in just quadrant 1, where all your coordinate pairs, x and y, are positive. Now, it's going to change a little bit in middle school, because again, we're going to be able to graph in all four quadrants. Now, first, let's talk about, again, we have four quadrants. They're normally numbered with Roman numerals. We start with 1, because this is the first one you learned. And then we're going to go in a counterclockwise. Okay, don't ask me why, but we're going to go in a counterclockwise motion in numbering these. So this is 1. This would be 2. This would be quadrant 3. And this is quadrant 4. Roman numerals. And again, the V stands for 5. 1 in front of the V means 1 before 5, which is 4. Okay? I'm going to erase this. Now, as you know, we have our coordinates x and then y. Why does x come first? Well, x comes first in the alphabet. It's important that we realize x goes left and right. A student of mine once said, of course, obviously, we have the horizon, but we would always say horizontal. So x goes left and right. And y, obviously, goes up and down. The way I remember that is a capital Y, the stem goes up and down vertically. So again, y goes up and down. So when we graph the points, x comes first, x goes left and right, and then y goes up and down. I know sometimes in elementary school, your teachers talk about run before you jump, but obviously we don't use that anymore because we're dealing with all four quadrants, so we don't say you run before you jump anymore because that doesn't always apply to the coordinates that are given. And I want to talk about the coordinates. Now, if it were in quadrant 1, our points would be both positive, because on a number line, if I go to the right, x goes first, x would be positive, and if you're going up on a number line, that's positive. What if we were in quadrant 2? What would our coordinates be? Well, on a number line, if we go to the left, your x value would be negative, but we're still going up for your y value, so that's positive. All right, what about quadrant 3? All right, so quadrant 3, we're going left on the number line, so our x value is negative. Our y value, we're going down, so that's negative as well. And then for quadrant 4, we're going to the right on our x value, so it's positive. But for our y value, we're going down, so it's negative. So you can refer back to this if you forget your coordinates, where the point is, should your coordinates be positive or negative. So hopefully this helps. So let's look at some problems. This is from the 2018 test. The coordinate grid shows points P, Q, R, and S. All the coordinates for these points are integers, meaning they don't have a decimal or a fraction. What is the value of point P? Now, of course, we're filling it in on a gridable. We're just going to talk about it. So again, they want the points, so it's just the x coordinate. We're not doing the y. We're only doing the x. So the x goes left and right. And so we start off at 0. 0, 0, that's the origin. That's where you start off. Okay? We're going to go left, and you just have to figure out how far left you go. On this one, this is kind of easy. You went 6 over to the left. Since we're going to the left on the number line, our answer would be negative 6. Now the y value, I did ask, obviously you go up 2, so it's 2, but again, we're only focused on this, the negative 6. On a gridable, pay attention to the place value. So if you had your decimal, you'd put 6 here, and then you usually have a positive and negative. We would bubble in the negative, so our answer would be 6 because it's in the ones place. We bubble in the 6 down there, bubble it in, and make sure you bubble in the negative because it would be a negative 6. All right, next one. Coordinate grid is shown below. Which ordered pair describes a point that is located 4 units to the left of the origin? Now the origin is here, and 2 units below the x-axis. Now, well, they brought this up because I didn't talk about that earlier. The axis, now the axis is this line right here. This is the x-axis, and this line right here, if it were a line, would be the y-axis. Okay, so we're starting off again at the origin, and we're going to go 4 to the left. So 1, 2, 3, 4, and it's 2 units below. So we go 1, 2, and that's where my point would be. So again, x goes left and right. So we went to the left, so my point is going to be negative 4 over, and it's negative because I went to the left. My y value, I went 2 down below the x-axis. Since I'm going down, that's a negative value. I went 2 down, so it's negative 2. And then I just find the answer that matches up with this, and my answer is G. Again, we labeled the axis, y-axis, and the x-axis. Started off the origin, which is 0, 0. We went left 4, down 2. That's why our answer is negative 4, comma, negative 2. 4 points are graphed on the coordinate grid. Which ordered pair does not appear to be represented by one of these points? Now notice we do have some fractions on this. All right, so let's start off with A. 5 over 2. Another way of writing 5 over 2 is 2.5. So let's see. We have x and then y. So x goes left and right, so we're going to go over 2.5. That's a little too far. Sorry about that. Go over 2.5. That was terrible. We'll deal with it. And then negative 3, so we're going to go down negative 3. Well, that is a point. We're looking for what does not appear, so it can't be A. Let's see if it's B. So I'm going to go negative 1. That's my x value. I'm going to go over negative 1 and down 1.5, which would be right about here. Uh-oh. That is definitely not a point on the coordinate grid, so it is B. But let's just check, make sure we didn't mess up. C, 3.5, 3 halves, sorry, 3 halves. It's the same thing as 1.5. So let's go over 1.5, and then let's go up 2, because that's positive. And so up. So there, that would be C. This was A. C is there. D, x comes first, x goes left and right. We're going to go over negative 4, and then we're going to go up 1/2. And that is D, and that is there. So the only one that was not there was B. B was close, but no cigar. So again, the answer is B, as in boy. All right. Venetia graphed point G on the coordinate grid. She will graph point H at the location 5 units away from G. So let's identify where G is at. G, x goes left and right. So first you went over negative 4 over, and then you went up 3, so it's a positive 3. So we have negative 4, positive 3. Now I didn't say which way she went, and we haven't done 8th grade math, so we can't do the Pythagorean theorem, so it has to be a line like this or like this. Okay. Let's check A. It needs to be 5 units away. So A, negative 4 is the same. And then 5's different. Our y value is different. But how far is 5 away from 3? Well, that would only be 2 units away. That would be negative 4 over, 5 up. It would just be slightly above it. So it definitely can't be A. Let's look at, let me erase this 5 here. Let's look at B. Negative 9, 8. Well, this is 5 away. The x value is 5 away. And the y value is 5 away. But I don't think that's it. And let's look into y. So we go over negative 9, up 8. It would be here. Now, think about if you were walking. First, I'd have to walk 5 steps this way. And steps, miles, feet, who cares? 5 this way, and then 5 that way. Well, that's not 5 away. That's 5 and 5. That's 10 units away. Now, later on in 8th grade, you're going to learn about the Pythagorean theorem. Well, technically, if you're in compacted, you're going to learn about it next year. And it would be around 7 units away, but it's still not 5. So it can't be B. Let me erase some of this. Okay. So let's check C. Oh, I don't know why I did that. Let's check C. So I have 1, 3. So our y values are the same. So that's 0 away. But what about -4 and 1? What is the difference between -4? Difference between -4 and 1 would be -5. But in distance can never be negative. So even though we got -5, your answer is going to be 5. I think it might be C. Let's check it out. 1 over 3 up. Okay, 1 over 3 up. That's 1, 2, 3, 4, 5. All right, well, I'm thinking it's C. Let's double check just to make sure it's not D in case we made a mistake. D, -4 over, -1. Our x value is 0 away. It's the same spot, -4 over, and then it went down -1. But 3 minus -1, if you find the difference, and again, two opposites, opposite of addition is subtraction, another opposite of subtraction is addition, is 4. So this would be 4 units away, which is close, and we can prove that. 1, 2, 3, 4 units away. That's close, but not 5. So again, our answer is D as in dog. All right, last one. Which point best represents the ordered pair -2.5 and 3? All right, so x goes left and right. We start off with x. We have -2.5, so we're going to go over to the left because it's -2.5. And then 3 is positive, so we're going to go up. And this was easy. This was B as in boy. So hopefully we've learned something about coordinate pairs. X goes left and right, y goes up and down, x comes first, then y, because it comes first in the alphabet. We learned about quadrants. Quadrant 1, 2, 3, and 4. And we use Roman numerals. And then in this diagram right here, we talked about if your coordinate is in if your point is in one of the quadrants, we talked about what the x and y values, whether or not they'd be positive or negative. So hopefully this has made sense. If you have any additional concerns or questions, you can email me. I hope you've enjoyed the video, and I hope you have a great day. Thanks.